I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have enough.
Hello and welcome back. In this part, we're going to do an AM alignment on this radio. Now, I've already done an AM alignment using the traditional signal generator and voltmeter, but I'm going to use the Whippleway WSAB board here for a fresh alignment. And it has a feature toward the end that you'll appreciate, I think. But for the initial alignment of the radio, the AM section, it's pretty much standard stuff, with the exception you're using the WSAB board for a signal generator, a non-modulated signal generator. It will generate 455 kilohertz. We're feeding that into the antenna clip right here, and I'll show this on the schematic. We're measuring the voltage across in this radio's case across the third IF pin 4. That's where the audio comes out of the detector. The other thing I've done is grounded the local oscillator capacitor up here on top. So I've just connected to where that feeds through the chassis, run that to ground. That keeps the local oscillator from interfering with the whole process. So with the as I said, we're measuring DC voltage. So we should have some DC voltage. This is not modulated. This isn't even turned on yet. But right now we're showing at that minus 0.641 volts, which is what we would expect. Now let's back out a little bit. I'm going to adjust the camera so that you can see both the voltmeter and the WSAB board output. Okay, the procedure is to turn on the WSAB, which I will do right now. The display comes on. By the way, I should talk a little bit. It'll make more sense to you to know what I'm doing here. This red RCA plug right here leads to the lead that's connected to the antenna input of the radio. This lead, which is the sweep in, or marked as sweep in, isn't connected to anything. This is what, when you're doing a visual alignment, this is what picks up the output of the sweep operation. I've got it shorted together right now so it doesn't generate any noise. The potentiometer right here controls how much signal is going through here into the antenna. We want as little as possible. This button right here will switch the WSAB mode so that it's no longer sweeping. As you can see right here, it's sweeping. Every time it flashes, it sweeps. We want that to be non-sweeping. And I'll show you why. If we turn up the output so that the voltmeter can pick it up, you'll see the DC volts are all over the place. Maybe you can see that. Yeah, DC volts are all over the place because this is sweeping through the AM band. So I want to turn that all the way down, and I want to push this button once so that we get this readout. Now you'll notice it's no longer flashing. This is set center frequency. The center frequency is set at 455 kilohertz. Hopefully you can see that. with a step, well, it doesn't matter. So it's right now generating 455 kilohertz unmodulated, and as I turn the gain up on the output, you see that the voltage holds steady. So we no longer have the sweep stuff action going on. We have a very steady signal going into the antenna input, and we're picking up a very steady signal on the third IF transformer, the output of that. So the goal is to turn this up just enough so we can see a voltage here, and let's call it 6.3 volts, 0.63 volts, 630 millivolts, showing on the output of the AM detector right now. So that's fine. We'll leave it right there. And now what I'm going to do is start the alignment process. I'm feeding a signal into the very front end of the radio. I'm picking it up at the very end of the IF chain. There are 3 IF transformers in here. So what I have to do is start with the first IF transformer, which is up here at the top of the radio, which you can't see. First IF transformer, go to the primary and secondary and adjust those to peak that voltage, and go to the second IF transformer and do the same thing, third IF transformer and do the same thing, and then go back to the first one again and do it again. So I'll fiddle with the first IF transformer here, just so you can see what effect we have on the voltage shown. And after that, I'll shut it off, and we'll see and come back when I've got it all peaked. So I'm at the primary of the first IF transformer. I'm going to turn it to the right, and it's going up a bit. 0.82, 0.9. Then it's heading back down. So I want to peak it right there. 575859, 5857. So 0.959 is the peak by adjusting the primary. I need to get that. There it is. It dropped away. And I took the tool out. By the way, I'm using a ceramic screwdriver, so that's not affecting it. It's just the pressure I'm putting on the coil is changing a little bit. Now I'll go to the secondary. Do the same thing. That's going down. Here we are going up. Turning counterclockwise in this case. And then finding the peak, 941, 939, back to the primary. And peaking it again, and it was right there. So 941, back to the secondary. Anyway, you get the idea. So I've done the primary and secondary twice. I'll do it one more time off camera. What I'll also do is go ahead and do I'm working right now on the first IF transformer. I'll go ahead and do the second and third, so you don't have to watch and sit through that, but the process is exactly the same. So I'll do that, and we'll stop this for a moment. I'll be right back. Now let's see what the WSAB board can do visually for us in AM alignment. The setup is pretty much the same. I've got the sweep output connected through, I didn't mention this before, I don't think, but it's connected through a 0.005, 0.01 microfarad capacitor to the antenna input of the radio. In place of the voltmeter being connected to the audio output of the radio, I've got the WSAB board sweep in the second connector right here, connected via a 220K resistor, just to keep the voltages manageable. Volume is down all the way on the radio. What we can do here, I have reset. Well, let me show you. When we were using the WSAB as just a signal generator, I had pushed this button once, and it went into signal generator mode. It's not flickering. That means it's not sweeping. And also, if you have, for example, a radio that has a different center frequency than 455, you can adjust that by turning this second stepper switch here to whatever you want. 465, if that's what your radio uses for an IF frequency, 460. In this case, it's 455, so I'll put it back there. If I push this button one more time, then it lets me change the sweep width. The sweep width right now is 30 kilohertz. That's fine. I don't need to change that. I can, again, using this stepper switch right here, so I'll leave that there. I push it again, and I can change markers. 450, so we've got a 5 kilohertz below the center frequency is a marker. If I push it again, I can change the high marker, and it's 460 kilohertz, or 5 kilohertz above the center line. If I push it one more time, it goes back into sweep mode. Now you can see it flashing. What it's doing is sweeping. It's sending a signal out this, sweeping from below 455 to above 455. Again, the local oscillator is disabled, so it's not interfering. We've just got a straight swept 455 signal going into the radio. Now, oh, by the way, these two knobs on the right-hand side, the one here, the left one, controls how big the signal is that's going into the antenna connector on the radio. I'm going to leave that right where it's at. The second one controls how much the signal coming in from, in this case, the audio output of the radio is being amplified. So I've got this set, I don't know, wherever it was. I'm going to turn up the incoming signal, and we should start to see, now we're starting to see a nice curve right there. Hope you can see that. Yeah, that's showing us that the center of the swept signal coming in, or the how can I put this? This is the response curve for the swept signal. The radio is giving us this response curve. It should be centered on 455. It's not quite. It's to the right a bit, so it means. So I need to make some adjustments on the IF cans to pull that back, but I can also make sure that it's peaked as well. So I can do some adjustments here, and hopefully you can see that as it's lying there. I can zoom in on it a little bit there. I'll take my ceramic screwdriver and make a few adjustments, and you can see, as can I, what difference this makes. I'm at the third IF right now. I'm just going to tweak the primary back and forth a bit. You can see I'm losing peak. So I turn it back the other way, and I'm gaining peak. And it's shifting a little bit to the left, right there. So it's peaked and a little bit to the left. Now I'll go to the secondary of the third IF. And we'll see what happens when we adjust that. We're not getting any more peak. We're peaked about there. I'll go back to the second IF. And again, we're not getting any more peak, but I can shift it a little bit to the left, which is what I should be doing. So it centers right on 455. And then the secondary of the second IF transformer, if I can get to it, there it is. I've got a little bit more left, then it starts to drop. So that's okay, we'll leave it right there. And finally, the first IF primary. Yeah, so we've got it centered nicely on 455 right there. The other thing to look at is we've got a pretty balanced waveform. Right at the bottom here, let me get a pointer. There's a pointer. Right here at the bottom of the display, you'll see 3 dB measurements. This is the dB measurement for the left. Well, let me back up. The center point is where we want that to be at 455. Then we've got some bandwidth measurements here indicated by these red lines. And those are pretty evenly balanced. If this was not a nice symmetrical waveform, you would see an imbalance between the left side and the right side in terms of the dB measurements. So this is around 13 dB, minus 13, minus 12, which means it's a really nicely balanced AM signal right there. So I don't think I'm going to be able to do much better than that. It's pretty much peaked, it's right on the center, it's nicely balanced, left and right, so that's as good as I'm going to do. So with, you can use the WSAB as a plain unmodulated signal generator, and it will give you the, with a voltmeter, as you normally would do an alignment on a radio, on an AM radio. But then you can come back in and check it out visually as well, and get it a little better. So we're all three, and three in this case, all 3 IF transformers are doing their jobs. We've got a peak voltage right at the 455 mark, and that's as good as we're going to get it on this radio. So that's, roughly speaking, how you do an alignment using the WSAB, and AM alignment using the WSAB board. Next video, we'll do FM side, see how that looks. See you next time.